Hi everyone, this is Kaushik working as Assistant Professor in MLR Institute of Technology in EC department. In today's session, we're going to discuss about complements and subtraction using the r's complement as well as r-1's complement. Okay, looking into the overview, first we're going to discuss about different arithmetic operations. After that, we're going to discuss about r-1's complement and r's complement. And before that, we're going to discuss about what is actually complement. And after that, we're going to discuss about how to perform subtraction using the r-1's complement method, as well as we're going to discuss about subtraction using r's complement method. Now we are looking for the r-1's complement and r's complement. What is complement actually? In general, if you're looking into the set theory, for example, let's say that I'm holding two sets here. I'm having set A and set B. I can call this set B as complement of set A only if this set B holds the different values which are not present in set A. Got it? If the set B holding the values or the objects which are not present in set A, then only we can call set B as a complemented version of the set A. In generally, the complements in digital system design are basically used to reduce the complexity in subtraction. By adding the complements version of subtrahend values. In generally, what we are doing, minus, let's call it as m, and we are doing minus subtrahend, right? Rather than doing that, we are trying to m addition of complemented version of minus s. This operation will reduce the complexity in subtraction. That's what exactly we are utilizing. These complements, and that is the purpose of complements actually. They are just to reduce the complexity. Now, how to determine r-1's complement? Actually, what is r in r-1's complement? If you look into this r, we already discussed in our previous scenario, in our previous session, that r always represents our base or radix. That means whatever the number system, it doesn't matter. We are having a unique procedure. To get our r-1's complement. In case of if it is binary number system, that means 2 minus 1's complement. We're calling this one as 2 minus 1's complement. That means 2 minus 1, the resultant value will be 1. In case of decimal, 10 minus 1. 10 minus 1 means it is 9's complement. In case of octal, it is 8 minus 1, that is 7's complement. In case of hexadecimal, it is 15's complement. No one is going to ask you about all this stuff. Majorly, people are asking on these two only, 1's complement as well as 9's complement. Right? How to determine r-1's complement for any given number, right? In that case, firstly, you need to focus on maximum possible unique digit present in the given number system. Maximum unique digit. Okay. You are supposed to remember what is the maximum unique digit present in given number system. Okay, what is the maximum possible number system? What is the maximum possible unique digit? From that maximum possible unique digit, you are supposed to subtract the given number. For example, let's consider this one, 9's complement. Let's consider that we are performing the 9's complement. In that case, consider the given number as 5, 6, 7. If you are willing to perform 9's complement for this one, in that case, maximum possible available digit in the decimal value, it will be up to 0 to 9, right? 0 to 9. The maximum value will be 9. That means you need to consider each and every digit. You need to subtract each and every digit from the given number with respect to the maximum unique digit, and that will resulting in our r-1's complement. 9 minus 7, it is 2. 9 minus 6, it is 3. 9 minus 5, it is 4. And this is our 9's complement. 9's complement for the given number, that is 5, 6, 7. Okay. Let's focus on how to get r's complement. R's complement, it is, I just said that r represent the base or the radix. That means it is available like 2's complement, 10's complement, 8's complement, 16's complement. Just focus on these two. These are the majorly asked everywhere. So in that case, how to get the r's complement? Simply, in order to determine r's complement, you should be aware of r minus 1's complement, because r's complement is nothing but we are supposed to add 1 to the LSD digit of LSD means least significant digit. For that LSD, whatever the value which is generated in rn minus 1's complement, for that, in that you are supposed to add 1 to the LSD of r minus 1's complement. If this resultant value r minus 1's complement, in that, for that LSD digit you are supposed to add plus 1, and the resultant value will be your r's complement. Okay, let's consider some examples. In this, like let's consider binary. Let's focus on getting the 2's complement value as well as 1's complement value. If I consider the value as 1 1 0 1 1 0, okay, 1 1 0 1 1 0. If I'm trying to get 1's complement for this given number system, 1's means this is r minus 1 means 2 minus 1. That means technically they are asking for binary number system. They are asking for binary numbers. Binary number system base value will be 2, and the unique digits present in this one will be 0, 1, and the maximum possible unique digit is 1. That means each and every digit for the given number should be subtracted from the maximum digit only. 1 1 1 1 1 1. Now perform subtraction. 1 minus 0 it is 1, 1 minus 1 it is 0. 1 minus 1 it is 0, 1 minus 0 it is 1, 1 minus 1 it is 0, 1 minus 1 it is 0, and this is our 1's complement for the given number. This is the given number for this. This is my 1's complemented answer. Get it? Now if you are trying to get the 2's complement for the same given binary number, in that case the resultant r minus 1's complement value will be is 0 0 1 0 0 1. This is the 1's complement value. For this LSD, least significant digit, and this is my LSD, for this one you are supposed to add plus 1 to get our 2's complement value for the given number. Plus 1 plus 1 it is 1 0. Again 0 plus 1 it is 1 0. Rest of the values are, we don't have any value, so straightly write as it is, and this is my 2's complement value. This is my 2's complement value for the this number. Okay, now let's focus on discussing how to perform subtraction using r minus 1's complement method. Here are the steps which are already given. I already mentioned them, but let's focus. Obviously we need to perform subtraction. For subtraction we do require two numerals. One of them is called as minuend and another one is called as subtrahend. Between these two numerals we are performing the subtraction. Like I am representing this as m, minuend, and this is my s. So this is a procedure. First focus on identifying the minuend and subtrahend. Identifying minuend and subtrahend, whatever the values, whatever the numerals it given, it might not be given straightly in terms of decimal or number. Whatever the operation that we are trying to perform. For example, if you are trying to get 9's complement, it might be represented as the question might be given in terms of binary also. Still you need to convert that value into the decimal, then only you are supposed to perform 9's complement. For example, if you are performing the 1's complement subtraction and if the numbers are given in terms of the decimal values, in that case you are supposed to convert the given decimal values into the binary, then you are supposed to perform the 1's complement subtraction or 2's complement subtraction. Okay, now you guys understood how to identify the minuend and subtrahend, right? The values will be represented as m and s like this. Certain base value r. Okay, this is our minuend and this is our subtrahend. Okay. Now, what is the next step given in here? It is find r minus complement of subtrahend. Why we are not supposed to find r minus 1's complement of minuend? Because this value is clearly a positive value. Clearly it's showing like a positive value because the minus value, minus sign, it is indicated right before the subtrahend, right? Even if you are representing, even if you are finding r minus 1's complement for a positive value, it is straightly a regular binary only. A regular number system value only. It need not be binary. It's a regular number system value only. That's why we don't need to perform r minus 1's complement with respect to the minuend. Okay. Now focus on getting this subtrahend. Okay. Now, what is the step given? Find r minus 1's complement for the subtrahend. That is nothing but you need to consider firstly positive value. What is the positive value for the subtrahend? There you are supposed to get your r minus 1's complement for this positive value, and that value itself the r minus 1's complement for the negative number. Then afterwards, after you getting this r minus 1's complement for the subtrahend, you are supposed to perform addition operation with respect to the given minuend and the resultant value of r minus 1's complement of subtrahend. Okay, after performing addition, it might generate some amount of some value, right? After addition, it might be generating some value. Now, it need not to be a correct value. You need to correct the value by following these correction methods. One is you need to observe after addition, if there is any carry, then the result is considered to be positive. If there is any carry is generated after the performing addition, then it is the result value is considered to be positive, and that carry should be added to the sum value. That carry is added to the sum value. Remember, in case of r minus 1's complement, you are supposed to add this carry to the sum. Okay. Now, what if it is not generating any carry? That means after addition, if there is no carry, or let's say that we perform the addition and it is not generating any carry. In that case, the result is considered to be negative, and whatever the resultant sum, that is considered to be negative. And again, you are supposed to find r minus 1's complement of this resultant sum. That is my third step. Okay, find r minus 1's complement of sum. That is represented as third step here. That means we are performing r minus 1's complement for the resultant sum of minuend and r minus 1's complement of subtrahend. Okay, now let's try to implement these steps into the problem. Okay, we are perform the binary subtraction here itself, where it is clear to binary basis to subtraction of the following numbers using 1's complement method. That means the numbers are represented in terms of decimal number system. You are supposed to convert them into binary. Then only you are supposed to perform subtraction using the 1's complement method. Don't straightly do the don't go for the directly subtraction. You are supposed to convert, then you are supposed to perform the subtraction using the 1's complement method. Okay, let's convert this value. 45 of base of 10. You are supposed to convert that into the base value of 2. That means you are supposed to divide this 45 with respect to the 2, right? 2 to the 4, again 2 to the 4, 44. That is remainder value will be 1. 2 11s are 2, that is 0. 2 5s are remainder value will be 1. 2 2s are remainder value will be 1. 2 1s are. So this is a resultant binary value for 45. The 45 with base 10 and its equivalent binary value will be 1011 01. This is the equivalent binary value. Now how about 21 then? 21 should be converted into binary. In that case, 2 10s are 20 and the remainder will be 1. 2 5s are, sorry, it is 0. 2 2s are remainder 1. 2 1s are, right? 1 0. If you focus, 21 is represented as in terms of binary, that is 1 0 1 0 1 0 1. This is the equivalent value for the 21 in terms of binary, right? Now we are supposed to perform subtraction, right? whenever you're trying to perform subtraction, always focus whether the bit length is equal or whether it is containing equal number of digits or not. Look at this. In case of minuend, it is holding 6 bits. It is holding 6 bits, right? But this one is holding only 5 bits. This one is holding only 5 bits. In that case, add extra digit as 0. Now these two are holding the same amount of bits, 6 bits. Okay, adding 0 doesn't make any difference. Its digit value is 0, whatever the positional weightage, and again it's resulting into only 0 only. So nothing to worry. We are adding extra 0 in terms of MSB only, right? It doesn't make any difference to the actual value. Okay, we are performing subtraction, right? Now what is the resultant value? For 45 it is 101 and again 101. Let's write the value of 45, 101, 101, and again 21 it is 0, 0, 1, 0, 1, 0, 1. Okay, 0, 1, 0 and 1, 0, 1, right? Now this is my minuend and this is my subtrahend. According to the step, first step it is you are supposed to identify the minuend and subtrahend. We identified. The second step is our try to get the r-1's complement of our subtrahend. This is my subtrahend. Let's try to get the r-1's complement, and the question is to ask to perform subtraction using the 1's complement method. That means simply you are supposed to get 1's complement for this subtrahend. How to get that one? 0, 1, 0, 1, 0, 1. Each and every digit should be subtracted from the maximum possible unique digit value with respect to the given number system. In that case, the maximum digit value here it is 1. Simply 1 minus 1, 0, 1 minus 0, 1, 1 minus 1, 0, 1 minus 0, 1, 1 minus 1, 0, 1 minus 0, 1. This is my 1's complement for what? 21 of 10, right? Now let's perform the addition. That is our third step. This is my second step. Identifying is my first step. And third step, we are supposed to perform the addition with respect to the minuend and r-1's complement of the subtrahend, right? So in that case, the value of the 45 is minuend, that is 101 and again 101, and the resultant of r-1's complement, that is 10, 10, 10. Now you are supposed to perform the addition, right? Now 10 it is 1, 0, 1, 1, 1, 0, 1, 1, 1, 1, 0, 0 plus 0 plus 1 again, 1 only, 1 plus 1, yeah, it is generating carry. It is generating carry. What we discussed during the result correction, it might be generating some value, but for the sake of result correction, what we are supposed to do? Focus on whether it is generating the carry or not. In this case, it is generating the carry. In that case, my resultant sum is a positive value. Resultant sum is a positive value. And after that, for the correction of result, you are supposed to add this generated carry to the sum value. This one is getting added with respect to here. That means let me write it on the top. Okay, 0, 1, 0, 1, 1, 1, and adding this generated carry value here. 1 plus 1, 1, 0, 1 plus 1, 1, 0, 1 plus 1, 1, 0, 0 plus 1, 1, 1, 0. And this is my subtraction of 45 minus 21 and the resulting in binary. If you convert this value into the decimal value, just to verify the answer, in generally 45 minus 21, it is clearly 24. It is clearly 24. Let's check whether the resultant value is resulting in 24 or not. Try to convert this binary value in terms of decimal. Positional value 0 and its positional weight is 2 power 0, 2 power 1, 2 power 2 and 2 cube and 2 4 and 2 power 5. Positional value 0 into 2 power 5, it is nothing. 1 into 2 power 4, it is 16. And again 1 into 2 cube, it is 8. And again, and the rest of the values are zeros, zeros, zeros. 16 plus 8, 24. It's absolutely satisfying. It is absolutely satisfying. 45 minus 21, it is 24, as well as after this conversion, it is also resulting in terms of 24, right? In this way, you are supposed to perform r minus 1 subtraction. Okay. Next approach, subtraction using the r's complement method. That means the question may be asked in terms of 2's complement, or 8's complement, or 10's complement, or 16's complement, whatever the complement method. Majorly, people will ask 2's or 8's, or 2's or 10's. This is the kind of questions you usually get in your examinations. Okay. Procedure wise, it's almost similar. In the previous scenario, what we are doing, we are trying to find the r minus 1's complement with respect to the subtrahend. Here we are performing r's complement, because we are performing subtraction using the r's complement method, right? So you are supposed to find the r's complement for the subtrahend. Steps are common. Identify minuend and subtrahend. What is the minuend and what is the subtrahend? You are supposed to identify within the given problem, right? Next, focus on getting the r's complement of subtrahend. Then after that, you are supposed to perform the addition with respect to the minuend and the resulting value of r's complement of subtrahend, right? For the sake of result correction, what you are supposed to do, observe whether whether the addition is generating any carry or not. If it is generating, then the result is considered to be positive. If it is generating any carry, then the result is considered to be positive, and you are supposed to discard the carry. And this is the difference between the r minus 1's complement and r's complement method. In case of r minus 1's complement method, you can observe that in the previous scenario, here I am adding the carry to get our corrected result. What I am doing, I am adding the carry. But here, you are supposed to discard that carry. You are supposed to simply discard that carry to get actual corrected result. Okay. Now, what if it is not generating any carry? In that case, the result is considered to be negative. Then you are supposed to find your r's complement for the resultant sum value, which is generated in our third step. Okay, this is the procedure for subtraction using the r's complement method. Let's consider the same example. Just now we finished our 45 minus 21, which is represented in terms of the decimal. You are trying to get subtraction using the 1's complement. There you performed your first you converted the value into the binary value, then you then you perform the subtraction, right? Similarly, I'm considering the same example, but here I'm performing using 2's complement method. Now, what is the binary equivalent value for this one? It is 101, 101. Just now we perform. You can check it out. Whether it is correct or not. 101 and 101. And if you look into the 21, what is the value? 10 and again 101. Additionally, we are adding extra 0 just to make sure that both are having the same amount of bit values. Okay, same amount of bits. Here, the 21 can be represented as 10, 101, and additional bit 0. Right? These are the binary values. I'm not converting again because we just now converted that value. So just directly I'm copying those values here. Right? And let's try to, now we identified our minuend and subtrahend. This is my minuend and this is my subtrahend. That is the first step is over. How about second step? And second step is simply get your r's complement. With respect to what? Upon what we are supposed to find r's complement? On subtrahend. Now what is my subtrahend value? This is my subtrahend. For this value you are supposed to get your r's complement. R's complement means 2's complement. Here it is represented as 2. That means first try to get the 1's complement with respect to this binary number. That means 0, 1, 0, 1's complement. What happens? Let's try to get the 1's complement first, then we can able to get our 2's complement, right? 0, 1, 0, 1, 0, 1. For this, you are supposed to get your 1's complement. 1's complement is obtained from what? By subtracting the maximum unique digit. And the resultant value will be 1 minus 1, 0. And 1 minus 0, 1. 1 minus 1, 0. 1 minus 0, 1. 1 minus 1, 0. 1 minus 0, 1. This is my 1's complement, but we are supposed to get our 2's complement. For that, what we are supposed to do, add 1 to the LSD of the resultant 1's complement. I'm adding 1 to the LSD. LSD means least significant digit, or the rightmost bit you are supposed to add. For the rightmost bit, you are supposed to add 1, right? 0 plus 1, 1, and again 1, 0, 1, 0, 1. And this is my 2's complement for 21 of, technically it is minus 21, because we are performing addition, right? Like, the number actually given as 45 of 10 minus 21 of 10, but what we are doing here, it is 45 of 10 additioning. In the third step, what we are doing, performing addition minus of 21 of 10. That means it is total value minus 21. 2's complement will be this 1 0 1 0 1 1 1 0 1 0 1 1. Okay, let's jump into the third step. Right now, what is the 45 here? 45 is 101 101. Let's write it first. 101 101. Right now, how we are getting our minus 21 of base 10? 101 again 0 1 1 101 0 1 1. That's exactly right. Yeah, that's exactly right. Now between these two values, you are supposed to perform your addition. Plus 3. That is our third step. 1 plus 1 1 0. 1 plus 1 again 1 0. 1 plus 1 1 0. 1 plus 1 plus 1 1 plus 1 plus 1. That is 3 in generally decimal. If you convert the decimal value into the binary, it will be presented as 1, and here it is my sum, and here it is our carry value. 1 plus 1 plus 1 1 1. 1 plus 0 plus 0 1. 1 plus 1. Is the result is positive? Yes, it is positive, because it is generating the carry. Then the result is considered to be positive. Now what I am supposed to do to get the corrected result? Simply discard this carry. By discarding the carry, what is the value remain? It is 0 1 1 0 0. We just converted this binary value into decimal, and that value will be, it is 16, and it will be 8. 16 plus 8, that is equals to what? 24. 45 minus 21, that is also 24. In this way, you can able to perform not only 1's complement and 2's complement, you can also perform 9's complement, 10's complement, 7's complement, 8's complement. For all these complements, this is a similar approach that we can able to follow. Okay. In our next session, we might be discussing about BCD addition. We're going to discuss about XSD addition also. Thank you.